this out so you hopefully kind of see a little better. All right, so we're going to start to look today at how we can solve inequalities. So in lesson 7, you started looking back at how we solve linear equations. So those are equations that just have one variable. You're trying to get x alone. So inequalities, we're looking at the very same thing. We're looking at how to solve these, but instead of an equal sign, we've got our inequality symbol. So just looking at how we can solve some of these inequalities. So inequality is defined as a statement that compares two quantities, and they're not necessarily equal to each other. Inequality compares two quantities. And they're going to use the less than, greater than, less than or equal to, greater than. So oftentimes you might see inequalities out in the real world. So a big one, you guys are probably starting to drive, right? You guys driving yet? Nobody in here drives yet? Everybody can drive? All right. So you see a big inequality when you're out on the road. Maybe you don't always follow it. But what is out on the road that says you can go this fast, but not any faster? Speed limit. So right out here, the speed limit is 40. So you got 40 or less. So your speed, you can say S, has to be less than or equal to 40. We're also going to look tomorrow at what are called compound inequalities. An example of a compound inequality would be the speed limit on the interstate. So speed limit 70, but do you guys know what's the minimum speed you have to go on the interstate? 40. So you have what's called a compound inequality. Your speed has to be above 40, but it also has to be less than 70. So you see inequalities a lot of places. So driving is just one example. You jump on an elevator, you probably noticed the elevator has a weight limit, right? So your weight that's in the elevator has to be less than or equal to a certain amount. So a couple of properties of inequalities, so how we can solve these and what we can do. First, the addition and subtraction properties of equality. So the following properties are going to hold true. So as we're solving these inequalities, we have to follow these properties. So first, if you have a statement that A is less than B, so one quantity is less than the other, then if you add the same amount to both sides, the left side, the side with A, is still going to be less. So you have a statement that says A is less than B. If you add a constant amount to each side, if you add C to both sides, you're still going to have the A side is going to be less. And same thing if you subtract the same amount on both sides. So if we add or subtract the same amount on both sides of an inequality, it's still going to stay the same. The A is going to be the side that's the less than. Now when we get into multiplication and division is where we see a couple of curveballs. So next, if C is less than 0 and A is less than B. Now let's think about what type of numbers are less than 0. What do we call those numbers that are less than 0? Negatives. So if you have a C value, that's negative. So we'll just kind of put that more in layman's terms. C is less than 0 just means that you're dealing with a negative number. If C is less than 0 and A is less than B, then when you multiply A times C and you multiply the negative on the other side, B times C, it now changes the sign. It's going to make the AC side bigger. And you can do little quick tests, like you can do this, 2 is less than 3. If I multiply this side by negative 4, if I multiply this side by negative 4, now I have negative 8 and negative 12. So now looking at that, negative 8 or negative 12, which one is bigger? Which one is closer to 0? Negative 8, right? So now I've switched the sign. Now I've got that side is my bigger side. So whenever we multiply or divide here, we'll show that in a second, we are going to have our sign flip. We do that by a negative. So again, if you have A divided by C, that's now going to be greater than B divided by C. So the one little thing that we have to pay attention to is if we ever multiply or divide by a negative, it makes the other side the bigger side. And secondly, if C is greater than 0, which down here, if C is greater than 0, that represents positive. So C is positive, and A is less than B, the sign does not change. So our AC is still less than BC, our A divided by C is still less than B divided by C. So that does not change the sign at all when we have our number, whatever number it is that we're multiplying both sides of the inequality by. If it's positive, it's not going to change our sign. Lastly is the transitive property, which we don't use a ton, but just kind of a little reasoning thing. If A is less than B and B is less than C, then blank. So we could look at, like I'll do an example with my family. So I have a youngest son. His name is Luke. Luke is shorter than my daughter Lauren. And then Lauren is shorter than me. Now, how can I compare Luke and me? Is Luke going to be shorter or taller than me? Shorter. So if he's shorter than her and she's shorter than me, then he's obviously shorter than me as well. So we could say, we can make a connection between A and C. We can say that A is also going to be then less than C as well. So our transitive property kind of connects the beginning of that inequality to the end and says that, well, if this is less than this and then she's shorter than me, then I must be taller than that first person. So A is going to be still less than C. So a couple of properties. The big one is just when we multiply and divide by a negative, that sign is going to flip. So you're going to probably see that in your delta math. If you get it wrong, you're like, why am I getting this wrong? I'm doing all the algebra correctly. Well, if you ended up multiplying or dividing by a negative, that sign is going to flip the other direction. The other thing that we are going to do today is we're going to look at graphing. And when we graph inequalities, since inequalities, they technically have infinite solutions. To graph it then, we're going to use an open dot to represent greater than or less than, and then we use a closed dot to represent the less than or equal to, greater than or equal to. So open and closed are going to show that the closed dot, if it's an equal to, we're actually counting the solution that the dot is on. And if it's an open, we're not counting that solution where the dot is on. So we're only counting the solutions right next to it. So since inequalities have infinite solutions, we're going to graph them because then we don't have to worry about writing out all infinite solutions. That would just be a waste of time. I need to erase that little piece up there. Is that okay if I do that? You guys all right with that? All right. So look at practicing a couple and graphing, and then we're going to look at a couple of special cases. So example 1, we're going to solve out for our given variable, and then we'll graph where our solution set would be. So our first example, we've got m minus 4 is greater than or equal to 6. We're going to solve these exactly the same way as equations. So we're thinking, how can I get m by itself? So right now I have a minus 4. What's the inverse of minusing 4? What's like the opposite of subtracting 4? Adding 4. So we're going to add 4 to both sides. So that's what we looked at in lesson 7, kind of those inverse operations. We're going to add 4, add 4. When I add 4, the sign is not going to change. So I'm going to have m is greater than or equal to 10. Now when we graph it on our number line, this is kind of up to you, but I usually just put like a 0, and then I'll put the number that I'm comparing to. So I got a 0 and a 10. And then sometimes to make it more balanced, I'll put a negative 10 on this side just to show both sides of 0. Now we got to look at the solutions. So first I have a greater than or equal to, so I'm going to go right to 10. I'm going to put my closed dot. So to show that 10 is also a solution. M is greater than or equal to 10. So 10 is one of my solutions. But then what would be another solution for m besides 10? If I have to be greater than or equal to 10. Who can give me another number that would be a solution? Number greater than 10. 11, 12. So you got to think about it. So if I have an m that has to be greater than or equal to 10, it's got to be greater 11, 12, 13, so on. So you have to draw then a arrow representing, okay, I've got all my solutions going that direction. Part B, I'm actually running out of room, so we'll put part B over here. I got 3 times t minus 4 is greater than negative 6. Right there. We got to use the distributive property. So that was something we looked at back in lesson 7. So I got 3t minus 12 is greater than negative 6. Next, I got to undo my adding and subtracting. I'm working backwards through the order of operations. So add 12, 3t is greater than 6. Divide by 3, t is greater than 2. Now, on all my properties I used to start solving this, I did adding, don't need to flip the sign. Divided by a positive 3, don't need to flip the sign. So the sign is going to stay consistent as I work through that problem. Now we're just left with graphing. So again, we can make our 0. Here's where 2 would be. Here's where negative 2 would be. Open dot, t is greater. So I'm going to go to the right. So I got an open dot on 2. So 2 isn't a solution, but anything right next to 2 is going to be a solution. Yep.
Sometimes I'm trouble paying
with the notes.
yeah.
Yeah, I can help you with that later. Okay, so that's how we can start to look at solving, graphing our inequalities. Example 2, when we're solving those inequalities, we're going to be looking at, you can put a little note here, these are going to be special cases. So you're going to see something happen here that is a little different than what we had above there. So we'll start solving out the right side. I've got a little distributive property to do, so we'll do that. So we got 3x minus 3 is less than 2x plus 8 plus x. Then we start to combine any terms, so the x's on the right can combine. So I'm going to have 3x minus 3 is less than 3x plus 8. Now the next step we would do is we would try to collect these variables on the same side. But you can kind of think ahead. What's going to happen when I subtract 3x over to that side? What's going to happen to my x's? Poof, they're gone. They're going to disappear. So at this point, since you have the exact same amount of x's on the left side, exact same amount of x's on the right side, we can cancel those out. And now we're left with negative 3 is less than 8. And we check, is that a true statement? Yep, that is a true statement, which is going to mean in turn that this one has infinite solutions. So it doesn't matter what number you would put in for x, it's going to work. Your right side is always going to be 11 more than your left side. So it's always going to be true no matter what we look at there. And for my next problem, I'm just going to shift it over to the right over there. And we'll put it in a different color. You can continue to work below there. But that next one, so I don't have to erase my screen, I'm going to go 4m plus 3 is less than or equal to 4 times m minus 3. So we got a little distributive property again. I'm going to have 4m plus 3 is less than or equal to 4m minus 12. Again, you see the 4m's and 4m's. What's going to happen there? Boom, boom. Now we've got 3 is less than or equal to negative 12. And you check that out. Is that true or false now? False. 3 is not less than or equal to negative 12, so that's false, which this one means that there is no solution. So it's not going to work for any number. So any number you put in, I'm never going to get it to work. The right side is always going to be less than the left side, which doesn't match up with how that symbol is put. So our special cases, we'll sometimes see where our variables cancel, which means that it doesn't matter what number you put in, you're always going to be left with those constants And then we can compare the constants. So how does the left side compare? It's true, so it's infinite. The right side is false, so that would mean that we have no solution. So that is the first half of lesson 12, and tomorrow we'll finish up, or sorry, lesson 10. And tomorrow you'll finish up lesson 10 on your own. You can finish up the last, just 2 problems. Today, though, the rest of the time is yours to work. If you want to work on the delta math for today or any other in the past, the rest of the time is yours. And I'll just be coming around to help out with anything I can. But the rest of the time is yours. I'll leave this up here if you need that anymore.
So it's not put the notes in.
So we have to insert that row. Do it that way. Or you can just write a little note to yourself about what it means. But that's all there. These are all extra copies. Here are extra copies of notes. I need those.